So, in your most recent lesson, you will have been looking at states of matter. Now, pardon the pun, why does matter matter? Well, matter is what everything is made up from, and we know that matter is made from atoms, as we've come across many times before. Now, key thing to bear in mind is that matter can exist in 4 states. Now, 3 states of solid, liquids, and gas are the ones you need to be most familiar with, but there is also plasma as well, and this can get quite complicated to understand, so we're just going to stick talking about these 3 or 4 to begin with. Now, 4 states of matter depend on how much energy the atoms that are in that substance have. So as the atoms gain more energy, so if you were to continue to heat a substance, the atoms would gain more energy. As you continue to heat the substance, then the state of matter changes. Now, whenever we change from one state of matter to another, we go through different processes. So if you think ice to water, ice is a solid, water is a liquid. When you change from one to the other, you're melting the substance. When you're changing from a liquid to a gas, so one to the other, you are then evaporating the substance. Now, and then the other way around, if you are going from a gas to a liquid, you need to know that the substance is condensing. If you think condensation on the window is obviously water, and that is water that's formed from water vapor in the air when that water vapor is cooled down, and then liquid into a solid. Again, think water to ice. You and I know that is freezing. So each of those are the processes between which substances change state. Now, if you are going from a solid to a liquid, the substance is melting. That substance, obviously, when it goes from that solid to that liquid, is what we call its melting point, which we would obviously measure in degrees Celsius. And the same again from the liquid to a gas. The point from where it changes state from a liquid to a gas is what we call its boiling point. And that would be the temperature which it did that. So if you think about melting and boiling points, if you have a substance that is between its melting and boiling point, it is a liquid. A substance that is above its boiling point, it would either be a gas or potentially even a plasma. And if you have a substance that has a temperature that is below its melting point, it's still a solid. Now, sometimes you can heat a substance incredibly quickly, so it can mean that it can go from a solid to a gas and skip out being a liquid, because you are giving the atoms in that substance so much energy so quickly that the bonds that hold the atoms together in a solid are broken apart so quickly that it becomes a gas. Now, the name of that process is sublimation. Now, let's just go over plasma briefly, because we need to know a little bit about it, and it's our 4th state of matter, and it only occurs in some elements. Now, once an element becomes a gas, if it's heated very quickly to 5,000 degrees Celsius, so that's hotter than you'd cook your Sunday roast at, it can change the number of electrons in an atom. Now, obviously, electrons have a negative charge, and if you're changing the number of electrons and where they are and how they move, it means that this substance, plasma, can conduct electricity really easily. Now, this has multiple different contexts and uses, but obviously you might be familiar with the term plasma TV. And this process and this interaction is involved in the production of that. And also it can quite easily occur in things like lightning strikes and also production of like neon shop signs. Now, the other thing to bear in mind that you need to know is about actually the properties of different substances when they are either solid, liquid, gas or plasma. So, I've got to bear in mind some things. If we think to begin with about a solid, and let's just change the colour pen to make it a bit easier for you to see. So, all of the atoms are in a fixed position. So they are in a fixed position and they are vibrating. So the chair that you are sitting on right now, the atoms in it are vibrating, but you might not be able to tell it. So if they're in a fixed position, that means that they are in a fixed shape. You look at the computer in front of you, it's a fixed shape, it's not changing shape. That's because all of the atoms that make it up are in a fixed shape and a fixed position. So we can measure its length, its height, its width, its volume, and those atoms, to make that easier, are often arranged in columns and rows. Now, if we think about a liquid, you pour a liquid from one glass into another, the liquid will, what we might describe as, take the shape of a container. Take the shape of a container. So you pour it from a top one to a big one to a little one. Obviously it will fill higher, and if you pour it from a little one to a big one, it will fill lower. So that's a property of the liquid, and the reason why that happens is because the atoms are free to flow. They're still touching, but they can move around randomly between each other because the bonds that are holding them together have been broken, and therefore they've got much more freedom of movement. Now, the same can also be said of a gas, in that a gas will take the shape of the container that it is in, but the atoms, the bonds between the different atoms have been broken, so the atoms themselves are free to move, and they do this randomly, and they do this very quickly because they've had more heat added to them, so therefore they've got more energy, and that energy can manifest itself as kinetic energy. And then, as we've talked about already with plasma, it can conduct electricity, which is a property of it. It is obviously 5,000 degrees, so it's also very hot, and the atoms themselves, they lose or gain. Don't know what happened then. Let's try that again. They lose or they gain electrons. So that means they change their electrical charge, and my pen seems to be going all over the place today. So we'll just write electrons instead with a little e minus, and that electron shorthand. So those are your properties of states of matter. And the final thing to bear in mind is that sometimes you might see in a chemical equation brackets with little letters in like this, S and L and a G, and all those are telling you is the state of matter that the substance is in that chemical equation. So an S is solid, an L is a liquid, and a G is a gas. You might also see one is AQ, which means aqueous, which is another word for dissolved in water. But we'll come more to those when we look at chemical equations at another point. So that is states of matter.